Hey guys, welcome back to our series on cracking the coding interview. Today we're going to be solving a problem called remove duplicates. Feel free to pause the video to read what the problem is asking for. However, I'm going to explain through the description, but keep a few things in mind. First is that problem also happens to be a LeetCode problem. However, the only difference is that LeetCode gives us a sorted list, but this gives us an unsorted list. Okay, that's the first one. And also we've solved this problem twice in the past. The first time we used the set as some kind of buffer. The second time we used a hash map. Today we're going to solve it following this follow-up problem, saying we're not allowed to use a buffer, and also saying to use two pointers, okay, in O of n squared. So we're going to show you how we're going to do with 2 pointers. Without further ado, let's get right to it. As always, I like to assume the head of my list node is a node with a value of none. However, most people don't. Most people assume the head is the first node with an actual value. So that's the only difference between my assumption and LeetCode and how other people do it. I'm going to start off with 2 pointers. The first pointer, I'm going to call him PTR1, okay? And the first pointer is going to start off pointing at this guy. Obviously, this guy's head.next, PTR1. Our second pointer is going to start off pointing nowhere. He's going to start off pointing at none, but right away, we are going to make him point to the same value. We're going to make him point right away to the same value as this. So PTR2 points to the same value as PTR1. And then from that point, we're going to start iterating. So let's consider our first iteration. In this iteration, PTR1 and PTR2, both of them, and PTR2 are both at 0. They're both at 0, right? Keep in mind, I put indices to make this problem, the explanation, a little bit easier, but typically linked lists don't really have the concept of indices. But now PTR1 and 2 are both at index 0. Here, what do? As always, at every iteration, we're going to ask ourselves this question: is PTR1.value, is the value of PTR1 equal PTR2.next.value? Are these two things equal? In this case, let's see. PTR1 is 1. Is value of 1 equal to PTR2.next.value? Is 1 equal 1? In this case, yes, they are equal. In a yes case, what do we want to do? We only do one action. We say PTR2.next is gonna be equal to PTR2.next.next. Essentially what this does is saying PTR2.next, which is this guy, is gonna be equal to PTR2.next.next. So essentially that breaks off the connection right here. Every time you see a .next on the left side of the equal sign, it breaks off the next connection and connects it to PTR.next.next. So essentially a link. This effectively deletes this guy because nobody's next pointer is pointing to him. So we'll move on to the next iteration of our loop. At this point, okay, PTR1 is still at 0. So once we do this, PTR2.next equals PTR2.next.next. So the next pointer points here. So at this iteration, PTR1 and PTR2 are still both on 0, are still both at index 0. However, we're going to ask ourselves the same question again: is PTR1.value equal PTR2.next.value? In this case, what is PTR1.value? That is 1. What is PTR2.next? We've broken this connection, so now next is this guy. .value, that is 2. Are they equal? 1 is not equal to, so the answer is no. What do we do when the answer is no? We're just gonna say PTR2 equals PTR2.next. So this effectively, what it does is it moves PTR2 from right here to PTR2.next. So PTR2 is now right here. So you see what we're trying to do? We're gonna hold PTR1 and keep moving PTR2 until we see an element that's different than PTR1. Then we're going to move PTR1 to join PTR2. So effectively, the next line of code we're going to do right still in this iteration is say, outside of this if statement, is say PTR1 is going to be equal to PTR1.next. Now PTR1 is right here. What is PTR1.next? You see, so this next node is pointing to this guy. Technically, PTR1 also moves here. Then we're done with this loop. We're going to go on to the next iteration of the loop. At this iteration, PTR1 is obviously at index 2 also is ptr2 are both at index 2. They're both right here. So we're going to ask ourselves the same question we've been asking ourselves. Is ptr1.value equal to ptr2.next.value? In this case, what is ptr1.value 2? What is ptr2.next.value 3? Are they equal? The answer is no. What do we do in a no case, right? We're going to do the exact same thing we did in the previous no case. We are going to say ptr2 equals ptr2.next, and then we're going to, outside of the if statement, we're going to say ptr1 equals ptr1.next. So let's take care of the first one. ptr2 equals ptr2.next. So that moves ptr2 from ptr2 down to ptr2.next. So ptr2 goes here, pointer 2 goes here. So then ptr1 becomes ptr1.next. So pointer 1 follows suit and moves to the next guy just like pointer 2. So ptr1 comes here. So now they're both on the same index 3. So in this case, we're going to ask ourselves the same question again. So let's go ahead and write this out. Here, ptr1 and ptr2 would happen to be at index 3. So again, we ask ourselves the same question we've been asking ourselves. Is ptr1.value equal to ptr2.next.value? In this case, ptr1.value is 3, ptr2.next.value is 3. Are they equal? Yes, they are. What do we do in yes case? The same thing we did in the previous yes case, which was say ptr2.next is going to be equal to ptr2.next.next. Every time there's a .next on the left side of the equal sign, that effectively breaks the next pointer. So I'm going to break this next pointer and then point him to ptr2.next.next. So ptr2 goes to ptr2.next. Next effectively points to none. This is ptr2.next. So at the next iteration, this is the next and also happens to be our final iteration, right? ptr1 and ptr2 still happen to be at 3. We're going to ask ourselves the question, ptr1.val equal ptr2.next.val. In this case, obviously ptr2.next.val is none, ptr1.val is 3. They are not equal. In the no case, all we're gonna say is the same thing we did in the previous no case, right? ptr2 equals ptr2.next, right? So ptr2 equals tr2.next. So what this effectively does is move ptr2 from right here to next. ptr2.next is this guy here, so it moves ptr2 to none. So this effectively breaks our loop. Well, let's just go ahead and complete this. For ptr1, we're gonna say ptr1 equals ptr1.next, which also happens. ptr1 is right here. His .next is this guy because we've broken the pointer of this guy. So he also goes over to none, effectively deleting this guy. So that's it for the algorithm. Let's go ahead and put this to code and see how it works. Again, I've taken the liberty of creating a node class, which is the building block of our linked list class. And this class contains an append method, which is how we're going to build our linked list, and a display method to visualize our linked list. Here we create our linked list itself, and here we display it first, and then we're going to call our function. This is the function we're going to be working on right here to remove duplicates, and then we're going to display it after. So let's go ahead and run it now. It's going to give us an error. Let's say pass. Let's go ahead and run it again. Okay, good. It gives us the exact same because this function does nothing right now, but once we edit it, it should work. We're going to first initialize our 2 pointers. So ptr1 and ptr2. We're going to set ptr1 is going to be self.head.next. The only reason why I say .next is because I assume our head node is always a none node, right? Most people don't assume this. And I'm going to set ptr2 to none for now. Then what I'm going to say, a while loop, while ptr1, okay, while ptr1 is not none and ptr1.next is also not none, while both of these are not done, I'm going to set ptr2 equal to ptr1. So now that they're equal, now a second while loop to move ptr2. So while ptr2.next, while he's not none, okay, what I'm going to say now is the actual meat and potatoes. I'm going to say if ptr1.value is equal to ptr2.next.value. Okay, if these two guys happen to be equal, just exactly like we did on the paper, right? Then ptr2.next is going to be equal to ptr2.next.next. Okay, now else meaning they're not equal, the else case obviously. Then ptr2 is just going to be equal to ptr2.next, exactly like we did on paper. And then outside of this if statement, outside of this while loop controlled by ptr2, we're going to increment ptr1 is going to be equal to ptr1.next. I think this is correct so far. Let's go ahead and run him and make sure we get the right values. So boom, you see all the duplicates have been removed. 2 2s, just 1 2, 2 3s, just 1 3, 2 5s, 1 5, 2 9s, just 1 9. Let's go to LeetCode, right? This is the exact same solution. The only difference is ptr1 is head, right? Because LeetCode doesn't assume like I do that the first node is a non-node. LeetCode just goes straight here. This is the head node, so this node doesn't exist to LeetCode. That's why it's to head, not to head like I did it .self head.next. I'm sorry. Let's go ahead and run this, submit this, and see how we do. Success 55 percentile in terms of space, 5 percentile in terms of speed. It's not too bad, I'll take it. But that's it for the video, guys. I hope it was helpful. I'll see you in the next one.